So what are we comparing in this t-test? It looks like we're comparing 14 measurements, 14 student test scores, against a stated state norm of 74. That makes this a one sample t-test. You're comparing a sample mean to a stated population mean. Sidebar, important sidebar. Would this be a one-tailed or a two-tailed test? People get the one sample, one tail, two sample, two tail. They get that mixed up. No, don't do that. A one-tailed test of significance, remember, is if you pick a side. In other words, if you think this side is going to be greater than the other side, or this side is going to be lower than the other side, if you pick a side, it's called directionality. It's a one-tailed test. If not, if it just says there's a difference or they're not equal, that makes it a two-tailed test. So for our example, this would be a two-tailed test because the teacher just wants to know if there's a significant difference between the mean of his students' test scores and the mean of 74. Okay? Doesn't say if they're greater than or less than, so that makes this a two-tailed test. Unfortunately, SPSS does not do one-tailed tests in t-tests, but all you have to do to change a two-tailed test of significance to a one-tailed test of significance is divide the two-tail by 2, and that's how you get a one-tailed. All right, back on with the problem. All right, first thing, very carefully copy these numbers into SPSS. Did it already, so make sure you go to variable view, you name it. I named mine test scores. Since there's no decimals, I don't like to have decimals showing. And over here, the measure is simply a scaled number. So, got it? So now we're ready for our one-way or one-sample t-test. We simply go to Analyze, Compare Means, one-sample t-test. That is our testing variable. That's our DV. Check the options box. Don't care. This is about missing data. We're going to worry about that later. And the test value, very important. This thing right here, test value. What are we testing it again? This is the norm. And in this problem, it was stated as 74. Click OK. Get the output here. Let me move this over for you just a tad. T-test. So there's your sample size in. There's the group mean, 79.79. Seems higher than 74, but is it significantly higher? No. Here's the t-test statistics, 1.835, which represents the number of standard deviations. The sample mean is away from the stated norm, right? It's not quite 2 standard deviations. It's close. It's very close. And your significance, because this is a two-tailed test, 0.089. It's not less than 0.05, therefore you cannot reject the null. And there's the average distance between the two. So let me show you how to write that up in APA formatting real quick. And it looks like this. The one-way t-test was used, blah, 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 and did better or worse, right? That means not equal to. The results indicated no significant difference. T, that's the name of the test, parentheses, degrees of freedom, 13, equals the test statistic, comma, the p-value was 0.089. Now, in the old days, you would write simply p is less than 0.05 or p is greater than 0.05, but I think in the last couple of years, they want the actual p-value, which is no big deal. And remember, this is a two-tailed test. So, and also remember, if you don't have significance, don't bother about effect size or power or anything else. It doesn't matter. If you don't have significance, there's no further steps to take. All right, that's it. MGZ out.